All right, let's talk about doing restarts inside Ansys LS-Dyna today. So, agenda, right? What I'm going to talk about today is I'm going to talk about 3 different type of restarts, why we want to use them, and how to essentially set them up. And at the end, I'm going to demonstrate the 3 different restarts with 3 very simple examples, very similar, very simple examples, to sort of showcase how it works. Now there are 3 different restarts, right? The first there that is called simple restarts, small restarts, and full restarts, right? These are essentially increasing level of allowed amount of changes, right? So a simple restart is basically a restart, a continuation of a stopped LS-Dyna job, either at termination time or either before termination time, or interactively when you stop it by hand, right? There is no requirement for changing the input file. So when you set it up, all you have to do is to remove the reference to the input file and then add an R equal to D3 dump file. The D3 dump is essentially a restart file that's written at the end of a Dyna job that essentially allows you to call on it to essentially restart an analysis. The NN essentially represents how many of these files are written. Usually it's like O1, O2, and so on and so forth, depending on how large the model is. Right, so that's basically a simple restart, very simple. Just restarting it, let the job continue the way it is, right? Now a small restart is basically very similar to the simple restart, except you can make very limited number of changes, right? These are including things like termination time. Basically, you can extend a model from, say, termination time at 100 millisecond to 200 millisecond. You can change the output interval, right? So if you want a higher frequency of D3 plot, for example, you can change that. You can also delete a body, delete contact, delete elements. You can also switch the stiffness type of a body, right? These are the type of changes you can make. Very limited. And then when you do this is very similar to the simple restart, except in this case you just have to call on an input file. So these changes will be placed into a new input file. You call that a restart input file, and that's going to be called out. And then you're also going to call the D3 dump file, which is going to initialize the small restart. Now the much more useful, in my opinion, is the full restart. The full restart is basically a second model, right? That's a continuation from the first model. You can make whatever change you want to it. The only requirement to do a full restart is you have to start the second restart file with a stress initialization keycard. And then the way you call on the full restart is the same as the small restart, is that you call the restart input file, and then you call the D3 dump if it's a SMP, you call it D3 full if it's MPP, basically. And this kind of expression is what you need to generate a full restart. But remember, you can make whatever change you want, which make a full restart very useful, because you can start a baseline model, then create 3 different subsystems, right? Subsequent analysis based on the first shared common initial step, right? So this allows you to save a lot of time. Instead of having to run the first portion of an analysis 3 different times, you can run it 1 time, then restart, then rerun 3 different analysis from 3 different restart input files, right? Which give you a lot of freedom to be very efficient in running a more complex model. Okay, so let's look at some examples on how these 3 different restarts are handled inside Workbench LS-Dyna. Okay, so what I have here is a very simple model. I have a beam, right, a little board. I'm gonna fix it on one end, and then I'm going to apply an initial velocity of this top piece, which is gonna hit against the board, cause it to bend down, right, as you can imagine. There is a friction, there is a surface contact, right here between these contact surface area here. And then when this happened, as you can imagine, the block is gonna bounce back and the board is gonna vibrate, right? Now during the first step, I'm actually turned off the damping card, right? So I'm not gonna have any damping in the model, which means the vibration is gonna keep going up and down, into forever, right? Into the termination time. In the second full restart, what I'm gonna do is I'm gonna introduce a damping card, which is going to cause the oscillation to come to a stop. Right, so that's my way of demonstrating a full start. So the way you do this is that inside Workbench you can actually drag a Dyna system here, and then drag a Dyna restart into the solution of the Dyna, right, which is going to give you a block that look like this, which is essentially what I have here. Now, if you look at here in the base model, you can, once you set up your model the way it is, right, ignore what I have here. I have a lot of different model in one place, basically. But if you write out the input file here, right, you can write out the input file, say, for example, into, I'm going to put it into a folder. I'm going to call it into my full restart folder, right? I'm going to do this, call this the demo, right? Demo full restart, oops. Demo full restart, right? And I'm gonna call this the initial.k, right? So this is my initial keyword file. And then for the full restart, once I set it up, right, I have the same boundary conditions, same D3 plots, and then I'm going to generate a restart.k, right? So what I have essentially in my folder now is a start file and a restart file, right? So if you look at what we did here, I have a start file and a restart file. Both of these files basically look very similar from the perspective of the input file, right? So I can show you the start file look like this and the restart file look like this, right? So the start file is basically the same input file you can imagine from an LS-Dyna model, nothing special. And if you look at the restart file, all I have here is a stress initialization. I'm sorry, this is the initial. Initial, it looks pretty much the restart. All I have relative to the initial model is that I actually have a stress initialization card, right here. You see, this is what essentially tells the program that everything that I'm changing is going to be a restart file because the presence of this keyword file here, right? And then what you do after that is that you basically just solve inside ls run. You solve your initial file, and then you solve your restart file following the syntax that I shared earlier, which is that you call the initial file, then you call the restart file, along with the dump file, which allows you to basically solve the model, right? So I'm not going to demonstrate that here because I have to wait for the solution to finish. What happens? What I will do instead is I will show you the result of one of these restart files. Right? So in this case, what we have is a actual full restart, right? So what I have here is I have a start file and a full restart file, as you can imagine, right? The only difference, as I mentioned earlier, the only difference is the damping card, right? And the restart file is actually going to be 0.2 second, whereas the start file is going to be 0.1 second, right? So you can sort of imagine, right? You see this in this model, the first 0.1 second, the oscillation. By the way, this plot right here is the nodal velocity of one of the node towards the end of this red beam, right? So as this thing oscillates initially, right, you can sort of see, because the lack of damping, the board will just keep going up and down, up and down, up and down. After you pass 0.1 second, the oscillation stops, right? Because I included a damping card, which is what eventually causes the oscillation to come to a stop, right? You can actually see the little things that probably need to be corrected, where the damping forces are causing these little weird edges to show up. But basically, this is what's happening, right? So basically, for the first 0.1 second is the initial model. For the last from 0.1 to 0.2 second is the restart file. The restart file is going to cause it to, because the damping card present in the restart file is going to cause it to come to a stop. So that's one way in which you can run a first version of the model without any kind of damping characteristic, right? And then you can restart that first analysis with the second analysis in a full restart by introducing damping, as well as introducing any other characteristic you wanted, right? And that's a very powerful use of a restart functionality within LS-Dyna. Okay, that's the first example for a full restart. Now let's look at an example of a small restart, right? So a small restart, like we mentioned earlier, right? A small restart is basically just a restart file with some very limited amount of changes, such as termination time, such as deleting body and contact. So what we're gonna do in a small restart model is that I'm going to run the same model here, right? Except instead of having a full velocity, right? I'm actually going to just press this block down by some distance for the first 5 milliseconds, right? and then I'm going to delete this block from the model in the simple restart. I'm sorry, in the small restart. In the small restart, because it allows me to delete a body from my analysis, right? I'm going to delete that body and see what happens to the board. So first step, I'm going to press it down, so you have a very simple bending problem. And in the second step, in a small restart, I'm going to delete this body, which is going to you can sort of imagine which is going to cause this board to rebound, right? Which is a way that I would like to use a very simple example to do a small restart. Now, as you can see, a small restart follow the full basic analysis, right? As you can see, when you do a small restart inside the analysis setting, if you set to a small restart, you can see this little tab showed up. In here, you can change velocity, change rigid body, change boundary condition, delete body, delete element, delete contact, like I mentioned earlier, right? But remember, what matters is not what's in the workbench environment. What matters is in the input file. So the way I actually like to do small restarts is to use a standard small restart cards, right? These cards right here are the standard small restart cards that you can always use. These database cards are relatively shared. You can turn a body from rigid to deformable. For example, you can change the initial velocity. You can change the velocity of a body. So for example, if the velocity of a body in the first analysis was 100 meters per second, in the restart, you can actually turn that into 500 or make it equal to 0. So it's a very easy way to essentially stop a body from having any velocity or having larger velocity. You can delete a contact from a previous analysis. The ID is the contact ID from the previous input file. You can also delete a part, and that's the part ID of a previous model, right? So in the example I'm doing, I'm going to use the delete body card, which allows me to basically delete the body that I wanted to do, right? So to show you the file that's actually used in the analysis, right? So I have a small restart file that I've already solved for the purpose of this video, right? So I have the small start, and then I have the small restart, right? So the small start is the basic model as I have done, right? The small restart is just a set of very simple keyword files, right? You have some similar termination times. So previous termination time is 0.005. In this case, the small restart, I change termination time to 10 millisecond, which essentially allows me to continue the analysis by another 5 millisecond, right? And then I'm going to delete part, which allows me to delete the part that I wanted to delete in the second half of analysis. So what happens here is that you can see this is the actual solution, right? Is that for the first half of an analysis, look at the time. Oh, actually, let me just do the animation real quick myself, right? So for the first half of the analysis, I have a very simple compression, right? Which is going to cause the beam to basically, deform down. And then once the restart starts, you can see that body immediately gets deleted. And once it gets deleted, the beam started to rebound back. Right, so suddenly like the external load got removed, right, which is what causes the beam to basically rebound back. It looks really weird because the time frame is very short, but that's basically what's happening. Okay, so that's a way to do a simple restart. The very useful way for doing a simple restart is that you can basically create a master simple restart file, modify it, and then attach it to any model you want without worrying about the mesh, worrying about the nodes, worrying about anything else. Right? You can actually delete any component from it. You can delete a contact from it by just changing the ID in here, right? In here. In the case of delete body, you can just input the correct ID here. You will delete that body from the model, which allow you to do a very simple small restart. Okay. Now, if we want to, the last restart demonstration is what's called the simple restart, which, as I mentioned before, right, it's a very simple way to, it's essentially a restart without changing your input file. It's basically just allow you to continue doing analysis, right? The best way to demonstrate this, right, is to essentially show you directly what happens when I do that, right? So for example, what I'm gonna do here is I'm going to write out an input file. Which I'm gonna use the input file that I created yesterday, right? So I'm just gonna demonstrate it. So for example, I'm gonna take this input file. I'm gonna take this start input file, right? And I'm gonna create a demo I'm gonna create a demo folder. Simple restart. And I'm gonna put it here. All right, and then I'm gonna go to my solve machine. I'm gonna go to my remote desktop to solve it. Actually, that won't work. All right, let me just solve it right here directly. Let's see if I can solve that right here. All right. All right, I'm just gonna solve this model. Oh, sorry, I need to delete this file right here. I don't need that. Okay, so this model hopefully will start solving. All right, so it's solving now. Right. What I'm gonna do here is I'm gonna look at the output file. Right. As you can see, the output file is gonna solve like that, right? And then what I'm gonna do here is I'm actually gonna forcefully cancel it once it reaches say 10%. Okay. All right. Well, I'm gonna stop it now. Okay. So now you see, once it reaches 10%, I just hit stop, which is stop the analysis, right? And you can see sort of like it stopped the analysis right at 1.03 to -2 second, right? Kill file detected. It's terminating the job itself. Now, if I want to restart this job, all I have to do inside autos run, right, is to add in the rd3 dump. And just to show you, right, there is a D3 dump that's actually generated inside here. You see there is a D3 dump 01 right there, right? That D3 dump file is created at the when I click on stop right here. This D3 dump is created, which allow me to restart analysis. But remember, in a simple restart, I'm no longer calling out the input file, so I have to delete that parameter for calling the input file, and then I'm just gonna hit solve again. And what this is gonna do is that it's gonna restart the analysis from where I ended up. You see, remember I started analysis before right there. Now it's gonna progress analysis again from the restart point, right? And that's essentially what simple restart is that if you terminate your model for any reason, right? You can just use the D3 dump file to restart your analysis from the location where it's terminated. And that's actually very useful, not from a simulation perspective, from a workflow perspective. Many times you have to terminate a job for a lot of different reasons, right? And this is a very useful way to do that. And I didn't know that until recently, right? And this knowledge would have saved me a lot of time when I was working before for another company. So very, very useful tip. So hopefully this helps you. All right, thank you.